Yeah, so problem 12 here, and I already made a recording of this that I really like. After like multiple tries, I found one recording that I really liked, but it was 25 minutes long, so I'm re-recording strictly to do better on time. Also, there's background noise, like, because I live in a noisy city, so like to kind of like, tune that out. I have soft music playing in the background. I don't know if you can hear it, but yeah, just ignore it, and I'm sorry that like if it's kind of unprofessional is like kind of out of choice, like, yeah. Okay, cool. Let's get started. All right. First, let's remind ourselves of what the tanh function is, and tanh is the hyperbolic trig function, which is the quotient of sinh and cosh. And if you take sinh and divide it by cosh and simplify that quotient, then you should be able to write e to the x minus e to the negative x divided by, and then it is this divided by e to the x plus e to the negative x. Yeah? Okay, cool. Alright, there it is. But wait, we're dealing with tanh squared, right? So we need to square here, meaning we need to square there. And now we've got a binomial right there and a binomial right there. And just quick reminder that a minus b squared, you should know this, just comes up enough times in this video that we should write it down. A squared minus 2ab plus b squared, right? And then a plus b squared is a squared plus 2ab plus b squared. So very symmetric, right? Okay, cool. So this numerator here assumes this form, and so executing the right hand side and also simplifying, we can write that the numerator here, after we square it, will turn into e to the 2x, that 2 is tiny, y'all, e to the 2x, and then minus 2, and then plus e to the negative 2x. And then the denominator is going to turn into e to the 2x plus 2, and then, ooh, that was poor, plus 2, and then plus e to the negative 2x, right? And now, remember, we can simplify both this numerator and the denominator, right? The denominator being this, obviously. We can simplify them both by first writing that so that it has a positive exponent. We can write that as 1 over e to the 2x, right? So I'll show you the simplifying step for the numerator, and then you could, like, use your imagination for the denominator, like very similar steps. But yeah, e to the 2x minus 2, and then plus e to the negative 2x, as I said, can first be written as plus 1 over e to the 2x. And then now, to simplify this further, we need common denominators, right? And so I have to multiply by e to the 2x over e to the 2x right there, and then e to the 2x. Right. I'm only multiplying by 1, right? Okay. Oh, no, sorry. I saw, like, a reflection. And anyway, you don't need that. Now, common denominators are like there, right? So we can write the numerator as e to the 2x all squared, and that's a product of those two, and then minus 2 times e to the 2x, and then plus 1. And then the denominator, obviously, is that common denominator of e to the 2x, right? Now, look here. This here, perhaps it's easier, a little bit easier if I write 1 as 1 squared at the end. But yeah, this here is clearly in this form. So it can be written as that. It's just that a is e to the 2x, and then b is 1. Check it. You can more carefully check it, but it is, right? So I can write this as e to the 2x minus 1 squared divided by e to the 2x. Now use your imagination of, how you go about that to get to a very similar thing as this guy. But yeah, this here, which is e to the 2x plus 2 plus e to the negative 2x by mimicking very similar steps to what I did there can be written as e to the 2x, and then it's plus 1 divided by e to the 2x. So that means that this quotient up here then can be written as simply e to the 2x minus 1 squared, and then divided by e to the 2x plus 1 all squared. And that's because I did this divided by that, right? Which is the same as doing this divided by that, right? Okay, cool. Hopefully you were listening. All right. And then I want to do a little bit of manipulating of this to make it friendlier when we actually start writing it inside the integral. Because remember, this right now is still just tangent squared x. We're just manipulating it more, right? So first we can, inside the parenthesis, write e to the 2x plus 1 in the numerator, but then I have to write minus 2. That way this is still the same as that there, right? Okay, cool. And then I have this is divided by the denominator, which is e to the 2x plus 1, and then I have all of this is squared. Well, that'll mean I have 1, right? I have 1 minus 2 divided by e to the 2x plus 1 all squared, right? Okay, cool. So now using the binomial square one more time, which is like this formula there. These are both called binomial squares, but yeah. Anyway, and I have videos dedicated to these, so you can check them out. But yeah, using this one, we can write this here as 1 minus, you can do it more carefully, but 4 divided by e to the 2x plus 1, and then plus 4 divided by e to the 2x plus 1 all squared, right? Okay, cool. There we are. And so there we are. And so we go that this integral here is the same thing as doing the integral of, well, since this here is just tangent squared, it's the same thing as doing the integral of this, right? Okay, cool, dx, right? And then this arrow to nowhere now we can get rid of. That was my last job, by the way, the arrow to nowhere. Not just kidding. Okay, so this here is the integral 1 dx, right? I'm just going to take care of that as a separate integral. And then it's going to be minus 4 times the integral of 1 over e to the 2x plus 1. And then it's minus 1 over, and then it's e to the 2x plus 1 all squared, and then dx. Yeah, there we are. And now you figure that what I'm gonna do for this integral is just do u substitution. And yes, if you guessed that, then good guess. So we're gonna let u equal e to the 2x plus 1. Then du will have to equal 2 e to the 2x dx, right? And then dx will have to be du divided by 2 times e to the 2x. Now notice that means dx is equal to du divided by 2 times u minus 1. And I write u minus 1 here in place of e to the 2x because if u is e to the 2x plus 1, clearly e to the 2x is u minus 1, right? Okay, cool. So making all these substitutions and then knowing that the integral of that is just x, we write that right now we have x minus 4 times the integral of, it's 1 over u, and then minus 1 over u squared, and dx is du divided by 2 times u minus 1, right? And by the way, dx multiplies both of these guys, right? Okay, cool. So first, we know that we want common denominator, so let's multiply by u over u here in this part. And next is, there's a missing parenthesis right here, so yeah, in case you cared, but yeah, there and there, and we can write a 2 here, right? And then we have x minus, x minus 2 times the integral of, this here is now u minus 1, right? So we have u minus 1, and then divided by u squared, and then we have times du divided by u minus 1. How wonderful, right? Because we can go boom, boom. And then we will have, right, let me get rid of this. So this is going to say x minus 2 times just the integral of 1 over u squared du. But that's saying x minus 2 times the integral of u to the negative 2 du. Right? And so this is x minus 2 times, the integral here is u to the negative 1. U to the negative 1 divided by negative 1, right? So this negative 1 there can cancel that and turn it into a plus. And then u to the negative 1 is just 1 over u, so taking care of both, we can just write 2 times 1 over u. And like I said, we'll need to change this to a plus, and then we have plus c. So that's to say that our final answer, remember our choice of u was e to the 2x plus 1. So so our final answer as of right now is going to be the following, which is right here, right? Our final answer as of right now is that our integral is equal to this here. But then we know that the u is right here. So our final answer as of right now is actually x plus 2 over, that is 2 divided by e to the 2x plus 1, right? Plus 1 plus c. Oh, Jesus, sorry guys. Plus 1 and then plus c, right? Okay, cool. So that's our final answer. But wait, if you had checked the answer on the MIT Integration B website, you'll see that they have as their answer the following, which I'll write right here in green so that we have a reminder. And their answer is x minus tanh x plus c. Now, you could either, just believe me in saying that our answer here is the same as their answer, or you can watch a little bit more of the video if you want to be convinced. So here is how I convince you that this answer is the same as the answer that they have. And that is because, well, notice from our writing up above here that, right here, that we had all along known tanh x is equal to e to the x minus e to the negative x all divided by, and I'm not enjoying this part of convincing you that our answer is the same, but because I feel like this video is already long enough, re-recorded it enough times, but it's okay, I'll do it. So this is tanh x. So now I could multiply it to get an equivalent form, and I could choose to multiply it by, say, I could multiply it by e to the x minus e to the negative x, or I can multiply it by e to the x plus e to the negative x. Choose whichever you want, but I'll choose this path. and now we have e to the x minus e to the negative x. I'm multiplying the numerator also, and we need that, right? So we have this, and now look at what we've got in the numerator. In the numerator, by our work earlier, this here is basically that squared, which we labored really hard to get to this divided by e to the 2x, right? So it turned out that this, what I just circled, divided by e to the 2x is just that, right? So, okay, so we know that it's going to ultimately turn into e to the 2x minus 1 squared divided by e to the 2x. So what I just wrote here is equal to that after so much manipulation. But it's manipulation we did earlier, which is why I'm not going to do it again. And then the denominator here, using difference of squares, is first equal to e to the 2x. I'll just write up here. It's equal to e to the 2x, and then minus e to the negative 2x. But note that this is the same as e to the 2x minus 1 over e to the 2x, which in turn is equal to, it's equal to e to the 2x squared minus 1 all over e to the 2x. In other words, this last thing that I wrote, this last thing that I just wrote, right here, let me move it over here. This last thing that I just wrote is equal to, well, it's not equal to 10 checks, that's for sure. It's equal to, I'm sure you're keeping track, but it's equal to that, what I just circled. So since this is equal to this, and this is equal to this, right? This quotient is the same as dividing this by that. But instead of dividing by this, I want to multiply by the reciprocal of this. And when I do, I get e to the 2x. And a lot of you like understood all this detail anyway, but you know, I wanted to be very clear. Go floating straight to their hearts. Listen now, we won't tell anyone, but you gonna tell the world. So life ain't then any fun. Let your visceral unfurl as you rise from your burning fiat. Go, right there. Go get my suitcase, would ya? You've thoroughly blown their minds, now I must. Alright, now, this here, right, is equal to e to the 2x. Oh no, I don't have room to write it there. Sorry. So what do we do? I know. Here. So this is equal to e to the 2x minus 1. You just don't exist. This here is equal to that. So proud. You celebrate. And this is equal to, by difference of squares, e to the 2x minus 1 times e to the 2x plus 1, right? Okay, cool. And look at what we can do. Right? And so every shopping mall, another grain. Alright, and this so equals gray eyes on a subway. Long before you were born, you were always to be a dagger floating straight to their hearts. And then right there, right? Okay, cool. And what now? Well, kind of like the same little trick that I showed you earlier, which is we're gonna write. So this is all just to get like an equivalent form of tanh x, so that I can show you how this expression there is the same as their answer, and they actually don't write plus c on any of their answers, but it's fine. It's fine. Okay, they're probably like, yeah, like we're good at this, like we don't need to write plus c. So we've got like plus 1 and then minus 2, right? We did that. This is like just a rewriting of that. And then we have this is in turn divided by e to the 2x plus 1, where now it's clear that this equals 1 minus 2 over e to the 2x plus 1. So this here, right, is equal to tanh x, right? So basically, let's get rid of all the middlemen and like claim tanh x slightly differently as being this, right? We know that tanh x is also equal to this, but as I just showed, we can manipulate this expression for tanh x and get an equivalent expression for tanh x, which says this. So then that means that my answer, this here, can be written as x and then minus, and then it's negative 2 divided by e to the 2x plus 1. Cutting drone. And so, like, you know, this here is just a mere rewriting of that. The second home that leaves you on your own. So I have x minus. Now, if you pay attention, this right here is equal to tanh x minus 1. Because if I write minus 1 here and minus 1 here, right, from both sides of the equation, then tanh x minus 1 would allow me to get rid of this. So tanh x minus 1. And let me, like, you know, make it less confusing, right? The minus 1 adjacent to the tanh x. Is that you at the end? Would you play in the street at night? So this here I can replace with tanh x minus 1, right? So I've got x minus giving up the fight. Okay, so you gonna let these Americans put another dent in your life. And then it's plus 1 plus c, right? Okay, cool. So plus 1 plus c we can just claim is just like plus c or plus k, some other constant if you so choose. But yeah, like I'll just write plus c here. Final chapter written in your head. And so, should be convinced now that my answer is the same as their answer, yeah? Okay, cool. I hope you enjoyed this. Take care.